Go outside, close your eyes, feel the warmth of the sun on your face. That warmth, 93 million miles, 8 minutes through empty space. And before that, thousands of years fighting its way from the center of the sun to its surface, just to land on you. Oh, that's beautiful, poetic. I'm moved. Here's the thing though, it shouldn't work. What shouldn't? The sun, all of it. 600 million tons of hydrogen turned into helium every second for 5 billion years, the energy of billions of nuclear bombs per second. And by every rule of physics we understand, it should be a cold, dead ball of gas. Okay, you're gonna have to walk me through that. The core of the sun is 15 million degrees. Sounds hot, right? I would say that qualifies as hot, Rajesh. But it's not hot enough, not even close. The protons in the core of the sun, the hydrogen nuclei trying to fuse, they are moving at the speeds that, if you do the mathematics, are about 1/400th of what's needed to break through the electric force keeping them apart. So you're telling me that the sun is moving on about 0.25% of the energy it needs to do its job? Oh, you're good in math. Thank you. But that's worst efficiency as far as I know. And yet, the sun on your face, the warmth on your face. So either the physics is broken or the sun has found a cheat code. Which one? The cheat code, and it's called the quantum tunneling. And it means that the sun never actually smashes its atom together. They merge without ever touching. Oh, I'm sorry. Without ever touching? Without ever touching. Looks like we're gonna need a bigger whiteboard. Alright, two protons, both positives. Positives repel positives. You've seen with magnets in school. Like poles push apart. I'm with you. Now, the closer they get, the harder they push back. Cut the distance by half, the repulsion force quadruples. By the time they are close enough for the nuclear glue to kick in, how close is that? 100,000 times thinner than an atom. Right, so not so close. Not close, and the electric repulsion at that distance is enormous. Physicists call it the Coulomb barrier. Now I'm going to call it for what it is, a wall. An energy wall so high that protons at 15 million degrees are basically rolling marbles trying to get over Mount Everest. And how fast are these marbles actually moving? The average proton in the sun is about 1.3 kilotron volt of kinetic energy. And the barrier? The barrier is 500 kiloelectron volt. That's not close but needs a push. That should never happen. Even the fastest one, the outliers, 1 in a trillion speed demons, might hit 10 kiloelectron volt. Still 50 times too low. So the classical physics looks at the sun and goes, nah. The classical physics says the sun is impossible. Every star in every galaxy should not exist. Cold hydrogen forever. And yet, here we are, getting sunburns. So something else is going on. So here's the shift. Protons aren't marbles. They are quantum objects. And quantum objects don't have fixed position. They're described by wave functions, a cloud of probability. So proton is smeared out, kind of, and it's most likely to be near the center. But there's real, non-zero chance it's somewhere else. And wave can do something a solid object can never do. A wave doesn't have to climb over a wall. It can leak through. Sorry, did you say leak through? If your voice hits a wall, most of the sound reflects back. But if the wall is thin enough, some of it makes it to the other side. In the quantum world, particles do the same thing. Most of the wave hits the barrier and bounces off. A tiny, tiny fraction seeps through. So the proton doesn't break the wall. It doesn't go over. It just appears on the other side. Not by force, not by speed, by probability. That's dumbest and most brilliant thing I've ever heard. It's called quantum tunneling. But honestly, the name undersells it. The idea is sun burns not because it's hot enough to force fusion. It burns because the universe is, at its foundation, uncertain. Particles don't have fixed position. They have probabilities. And sometimes those probabilities place them exactly where they need to be. So the sun is running on luck, deeply patient mathematical luck. Luck that has been rolling the dice 10 to the power of 37 times every second for 5 billion years. Okay, I'm going to need the actual numbers. You said tiny fraction. How tiny are we talking? In 1928, a physicist named George Gamow worked out the mathematics. He was originally trying to understand alpha decay, how particles escape from nucleus. Same principle. He derived something called the Gamow factor. It's an exponential, e to the power of a very large negative number. When you plug in those values for two protons in the sun, the barrier height, the particle energy, the tunneling probability comes out to about 1 in 10 to the power of 28. 1 in 100 billion per collision. Yes, per collision. If you put two protons in a room and waited for them to fuse through tunneling, you would be waiting longer than the age of the universe. Well, wow. Rajesh, that's not probability. That's rounding error. That's universe saying, don't even bother trying. Yeah, it's genuinely terrible. So how? Because the sun doesn't have just two protons. The sun has 10 to the power of 37 protons. Okay, that's a lot of protons. Yeah, and that's 1 with 37 zeros. And every single one of them is colliding billion times per second. So when you have that many dice rolls, 1 in 100 billion becomes inevitable. Not because any individual proton is likely to tunnel, because the sun is vast and patient beyond anything we can comprehend. So the sun doesn't smash, it waits. The sun is the most patient machine in the universe. It rolls cosmic dice continuously for billions of years, and the dice land fusion just often enough to power every star in every galaxy. That's surprising and shocking and beautiful. Honestly, way more beautiful than any version taught in the school. That's the thing about real physics. The real story is always stranger and more beautiful than a simplified one. Alright, I'm impressed. But you said there's more. You said the strangest part isn't even about tunneling. Yes, the strangest part is what happens after the wave functions overlap. Because once they do, you have to ask a question that'll mess with your head. In quantum machines, all protons are literally identical, and I don't mean they look the same, I mean they are fundamentally indistinguishable, even in principle, even to the universe. Okay, I need you to unpack all that because I've heard all neutrons are identical before, and I really never understood what it really means. Alright, two white marbles. You can't tell them apart by looking, but you could, in theory, paint a dot on one or find a scratch. There's something that makes marble A different from marble B, even if you can't see it. Right, they are two physical objects. Protons aren't like that. There is no hidden scratch, no secret serial number, no secret identification. The question which proton is which stops being meaningful question. It's like asking which part of an ocean wave is wave number 1 and which wave is number 2. So when the wave functions overlap during fusion, there was never a boundary to cross. Two protons were never truly separate individuals. They were two ripples in the same underlying field. Fusion isn't a merger of independent things. It's a geometric overlap. The ripples overlap enough that the nuclear force says, you are one system now, and binds them. So they don't smash. They don't even merge exactly. They just realize they were always part of the same thing. Exactly. The word collision is the wrong word. Fusion, literally melting together, is even slightly misleading. What actually happens is two expressions of the same fundamental field overlap enough, just enough, to form one stable configuration. No breaking, no violence, just geometry. That changes how I think about everything. Not just the sun, just the whole idea that things are separate, that there is hard boundaries between object. That's not just true at the deepest level. It's convenient story we tell ourselves for daily life, but the universe doesn't care about our stories. At the bottom, things bleed into each other. Okay, so fusion isn't a crash, it's just two waves realizing they were the same ocean all along. That's actually kind of beautiful. Every photon that has ever warmed a planet, every ray that has ever landed on a leaf and turned carbon dioxide into oxygen, every beam of sunlight that has ever touched a human skin, all of it exists because of probability. An exponential that says there's a tiny chance that particle will be on the other side of the wall it cannot climb. And the sun has been doing this impossible rolling of dice for 5 billion years. Without that, the universe is just cold hydrogen forever. No stars, no galaxies, no carbon, no oxygen, no iron for planetary cores, no calcium for bones. A thin, cold soup of hydrogen and helium, and nothing else. Darkness everywhere, silence everywhere. So we are not made of stardust, we are made of probability, of dice that happen to land just right. So next time you feel the sunlight on your skin, remember that warmth is the echo of mathematical ghost. Two particles that never touched each other, that were never truly separate, overlapped in a way that released a photon, and that photon fought its way through thousands of years of stellar interior, then 8 minutes of empty space, just to end its journey on you. The universe isn't a machine of collision, it's a dance of probabilities, and you're living proof that sometimes the dice comes up exactly right. If this way of thinking about the universe hits differently for you, subscribe, hit the bell. We do this every time. Find the places where reality is stranger and more beautiful than what we were told.